Welcome back. We're now into week number 5 of the course, and so we're a little more than halfway there. And I think this week will be an interesting one for you because we're going to get into using pandas this week, which will allow us to start interacting with data files and doing things that are perhaps a little bit closer to where your interest might be in terms of how you would use Python yourself. So I think this will be an interesting week. Using pandas as always takes a little bit of time to get into how things operate because it will be a little bit different than some of the other things we've done in Python so far. But we'll kind of ease into it with today's lesson, and as always, you'll have the chance in the exercise to apply the skills from the lesson and in class. Regarding the feedback, there's a couple things I wanted to say. One is in this week's exercise, there was a problem number 0 where I was asking for midterm feedback, and I was a little bit underwhelmed by the response rate. There were only 17 responses, and I do understand maybe some of you were thinking like, oh, well, only the driver should respond to this, but actually what I'd like to do is ask that maybe by the end of the week, if you haven't filled in this little midterm course feedback e-form, please do that, and then what I can do is I can post a summary of the feedback maybe in Slack, or else we can go over it at the beginning of class next time. Normally I would go over it today, but since there weren't as many responses as I was maybe hoping for, I figured that maybe it's better to get a better sampling of the students who are active in the course and then present the feedback at that point. So if you haven't done it already, if you were to go to the repository for exercise 4 or your personal copy of it, you should see here this problem 0 and make that a little bit bigger. And that'll take you to a link to this feedback form where you can fill in a few questions to let me know how things are going in the course. And yeah, it would be, again, great if you can do this by the end of the week, and I will try to then post a summary of the feedback in Slack so you all know how some of the other students are feeling about how things are going in the course. One thing I did see, I think I looked maybe a couple days ago at the feedback, and I did notice there were some comments about the size of the text on the screen. Like particularly when we're working in Jupyter Lab, that the size of the text was maybe a little bit too small. If that's an issue, please let me know. I'll try to make it bigger today, but like if it's still not big enough, it looks okay on my screen and it looks okay when I look at these because I'm sitting right next to it. But if it's too small for you to see what's going on, or if it's hard for you to read, please just let me know. I'm very happy to make the screen like zoom in more. I don't have a problem with that at all. So I just need to know about it because if you don't say something, then I can't obviously fix that problem. And I'm glad to see that that came up in the midterm feedback because that's something we can address then for the remaining three lessons. But yeah, let's see. There's a few additional comments here. One about docstrings for a file being confusing. It's a little bit, it is a little bit odd to have a function file where you put a docstring at the top of it, but often it's the case that you have a group of functions that are related to some set of operations, and just like an individual function that can have a docstring, you can have a docstring at the start of a script file that then gives information about what that module can be used for. So since I have Jupyter Lab open here, I'll start by zooming in a bit. Let's see. How is this size-wise for the font? Is that big enough? Like all the way in the back, is it okay? Yeah? Okay. So, we could do something like if we import the math module, just as an example, and then we were to do help math. There is descriptive text that comes up here that describes the math module, and this would be text that's basically acting as the docstring at the level of the file that contains all of these different math functions, or the group of files that contain the math functions in this case. So it kind of provides an overview about the different functions that are available in the math module, and in fact, looks like in this case even returns the docstring from each of those functions. So it is not a bad thing to sort of get into a habit of adding a docstring whenever you create a function, and if you have a script file with a bunch of functions in it, then you can also make a docstring to describe what those group of functions do. It's kind of for your own reference, but if you start using Python and continue using it for some period of time, it may be the case that you end up with these script files with 10 or 15 different functions in them, and it might be useful to have some documentation there to describe them. So yeah, that was the kind of idea with the docstring for the file. We didn't look at an example in class about that, but it's essentially working the same way it does for a function. It's also noted here, it's surprisingly easy to completely screw up an exercise. Yeah, I think I sort of sympathize and understand. That's, I think, the reason why it's useful to be active in Slack and to attend the exercise help sessions if you can, because you can sort of start down a path where you gradually make sort of a number of small changes and end up in a place where you're suddenly then very confused and nothing in the exercise seems to work the way you thought it was working before. So if you have questions, even little things, like please don't hesitate to put them into Slack and say like, I don't understand why this function doesn't work, or I get a syntax error here or a type error or something like that and I don't know why. Just put it in Slack and ask. And I mean, you can do your own first, attempt to look at things by going through Google and just poking around at what you can find online. But if you can't find anything and you want some help, again, Slack, I think, is the kind of number one place to go first, or to your programming pair or whatever. But that's a nice place to ask questions because probably there's other people who are dealing with the same issues. And if you ask a question in a public channel in Slack, then of course everyone can see the question and your responses. So that's very helpful in that sense. So that looks like how things are going so far for week 4. I think that's good overall. I hope that the sort of idea and the concept of functions made some sense to you. And we'll end up, I think this week we don't really create any of our own functions, but next week we'll be using functions in pandas. And so we'll come back to using functions again, and you'll get some more opportunity to practice with that at that point. So let's go here and take a look at the course webpage, or maybe I'll just ask, are there any other questions or things that didn't end up in the poll feedback? All right. So yeah, this week we are, as mentioned, moving on to working with pandas, which is a library for data analysis in Python. And we'll jump into basically the main part of our exercise, or our lesson rather, for today quite soon, and just start using pandas. But here's basically what we're looking at. We're going to get an introduction to pandas today, and we'll continue then next week with more advanced topics in using pandas. And the things that we're going to work on for today and for this week are going to be related to reading in data files and working with data that's more or less in the form of something like a spreadsheet from Excel, because as you'll see, that is how pandas represents data in the way that it operates as well, is sort of in a tabular or spreadsheet-like format. And then we'll also learn some ways in which we can do some basic data analysis using pandas and how to write out our data files to CSV formatted text file. And that'll be the sort of scope of what we're covering today. And yeah, maybe can say a couple words first just about what is pandas. I'm guessing that maybe some of you have heard of this pandas library before, but essentially it is a library designed for doing data analysis in Python that was originally written by Wes McKinney, who's also written some textbooks on using pandas that are quite useful resources. It's fairly widely used, especially in situations where you're dealing with data files and data processing. Myself, when I was first teaching this course, I didn't know anything about pandas because most of the time I was using Python for things like solving equations and making plots rather than working with data files. But as I've gotten familiar with pandas, I've started moving over from things that I was doing like in Excel or in other similar kinds of environments to doing things in pandas, and it's actually quite powerful and easy to use once you get a handle on how things are operating. One of the main things about pandas is it provides a data structure that's something that we'll see today, called a data frame, that is a bit different from some of the data structures we've used earlier, but for those of you who've used R before, the name data frame probably sounds familiar, and in fact, the data frames in pandas were designed to operate similarly to how they operate in R, because basically this was meant to be a replacement for some of the functionality in R that would work in Python when it was first designed. So these data frames are nice in the sense that they have labels at the tops of tops of columns and along the sides of the rows that allow you to figure out very easily how to access data in some kind of table format. And it also builds on a lot of things that are other libraries that are quite powerful in Python, including NumPy. We used to teach NumPy in this course, but for the majority of the students, it wasn't really that useful because it's a little bit more focused on kind of computational efficiency, not so much on user friendliness, although it's not unfriendly, it's not as easy to use as pandas, but it's very fast and it's optimized. It's mostly written in C, so it works quite efficiently, which means because this is sort of the engine that's being used in pandas, the data analysis that you do in pandas is also fairly efficient. So yeah, I mean, it's sort of more than just an easier to use NumPy because it, like pandas, also incorporates things out of the matplotlib plotting library so that you can create plots from data frames very easily, as well as some functionality from the SciPy library. So it's a sort of comprehensive toolkit for dealing with data in Python. And the last thing here is just that to note, we're going to work with CSV files for most of what we're going to do today, just because comma-separated text files are a very easy data format to work with, but pandas can read in data in a bunch of different formats, including Excel files. So if you have things in Excel already, you don't even necessarily need to convert them to start working with pandas, which is quite handy. And similarly, if you've used Stata or SAS before for statistical stuff, you can also read those files directly into pandas. And of course, you can go and read the documentation if you're interested to see more about how pandas works. But that takes us here to our lesson for today. So I'm going to go over to my Jupyter Notebook environment that I had open earlier, and first need to pull down today's lesson materials. So just as a reminder, you can go into the My Work folder, and once you're in the My Work folder, you can go into Notebooks, and inside there you can then go over and click on the Git plugin tab, or whatever you call this thing on the left side, and then you can click the button to pull down the latest changes. So what this should do is it should bring down the materials for today's lesson number 5. So if you're having trouble, problems that did occur was that people had made a commit to some of the changes they had made in the notebooks directory from one of the earlier lessons. And if you do that, it's not a bad idea, but the thing is that you won't be able to push any changes to this notebooks repository because you don't have permission to do that. So normally when you work on the exercises, you have permission to push changes to your own exercise repository, but this notebooks directory, or notebooks repository rather, I think only myself and a few of the instructors are able to modify that. And if you commit changes inside the notebooks directory, like you have notebooks here that you've modified and you go and make a git commit, the problem that's going to happen is that GitHub is going to want to basically merge the two versions of the files to be the same. And effectively, that's not a situation that we can easily resolve. So the best advice I have is don't commit any changes in the notebooks directory. or else it's sort of difficult to figure out an easy way to resolve them without just making a fresh new copy, which is what we ended up doing. So anyway, hopefully everyone now has this L5 directory here in notebooks, and you can go into the L5 directory, and we're going to start our lesson today with this notebook called Exploring Data Using Pandas. So in today's lesson, as mentioned, we're going to focus on reading and writing files, doing some basic analysis of the data that we have in the files using pandas. And to kind of kickstart things, we need to have a look here at the format of some of these data structures that we're going to encounter here in pandas for the first time. So these are, as mentioned, the pandas data frame, which you can see can be represented sort of in two different ways. So the way that you'll see it in Jupyter Notebook, if you, for instance, just type in the name of a data frame and run the cell, you'll see here in bold at the top will be the names of the columns in the data frame. So you can see things that might look sort of familiar, like temp and max and min. And then along the left side, you would have a column that has your index values, so that you could refer to, for instance, a single value out of this data frame by using a combination of the name of the column and the name of the row, or the index value of the row, to access that data. This same information is shown in the kind of normal Python format, like when you print things out to the screen. This is basically how it would look normally in Python, and it's just formatted a bit more nicely in Jupyter Notebooks to make it easier to read the data that's there. But this is the same information, just presented in two different ways. So as you can see, a data frame looks more or less like a table of values. Again, sort of similar to what you would see in a spreadsheet. And if you're to take a single column or a single row out of one of these data frames, you would get something that is called a pandas series. And a series is a slightly different format. It doesn't quite have all the same functions that a data frame has, because it is basically just a single column of values. So the temperature values that we have here in the data frame, if you take just that temperature column, you get a series. And when you print that out to the screen, it looks like this. You can see the name of the series in this case is called temp. And it also shows you the data type here as floating point numbers, decimal values with 64-bit precision. So you have a little bit of extra information that's shown there when you print out a series like this. So this is the sort of structure of what these look like. You can, of course, read a little bit more in the text description on the course page, and you can see here some terminology for things that we would refer to in our data frame. So we have index values, as mentioned. We have our data itself, so there's different values that are here, and then things like column labels that are somewhat intuitive ways to interact with the data you have in these tables. And also, as mentioned, if you take a single column out of one of the tables, you end up with a pandas series, and we'll do that in today's lesson. Just like data frame, the series does have index values that you can use then to access individual values from the series. But because there aren't more than one column, you basically only need one index to access an individual value, whereas in a data frame, you need to know what column and what row in order to get the value that you're looking for. So those are our new data structures that are coming with pandas. And of course, I can sort of talk about this ad nauseum, but maybe the easiest way to actually get a sense of how things are working is for us to start working with the data itself. And so for the data we're going to deal with today, we have some statistical data from weather data set from 2016 in June here in Kumpula. Our data file, if we just click on the link, or maybe just click it, you can see what the data file looks like here. So there's a little bit of a header information here that's got some comment lines at the start of it. And then you can see what look like the labels for the start, or the names of the different columns here. And then we have, as there are 30 days in the month of June, we have 30 rows of data with each one corresponding to a single day. So you can see, for instance, here, the year 2016, the month of June, 06, and the day in June, 01. That's what this year mode name means in this case. It's year, month, and day. That's just abbreviated and written in this format as 8 digits. Then we have temperatures. We have the maximum temperature for the day and the minimum temperature for the day. So that's what our data file looks like. And we're going to start interacting with this in pandas. You can find a little bit more information if you're interested, that this data file comes from the U.S. National Oceanic and Atmospheric Administration. I think that's what NOAA stands for. Webpage. They have a really nice and comprehensive weather data database that you can access to kind of get climate observations from essentially all over the world. I think there's something like more than 10,000 weather stations you can access. So we've just pulled data from here in Kumpula because that was an easy way to get it. So to get started working with pandas, and as we would normally do, we need to first import the pandas library, and we'll import pandas as PD, which is the sort of traditional way of doing things with pandas. Maybe I'll make this one click bigger. Is that sort of obnoxiously big at this point, or is that okay? I think as long as we don't have any really long lines, this should work. So when you press Shift-Enter on this cell, that will import the pandas library, make it usable for us. And our first step after that is going to be to read in our data file using the pandas.readcsv function. So if we just type in, for instance, let's call it data, and if we say pd.read_csv, we then need to give in quotation marks inside of the parentheses the name of the data file, and so we'll just scroll back up here and grab that. It's this Kumpula June 2016 with metadata is the name of the file. I think if you were just to start typing in like KU and then press the tab key, it will autocomplete the rest of the file name. So if you want to save yourself some keystrokes, you can also do things that way. If you don't want to copy paste, we can do it like that. So press Shift-Enter, and we then will read our data file into a variable called data in this case. One thing to note is when you read in the CSV file, there are ways to specify different separators between the column values. We have, in this case, commas, which would be the default that is expected for a comma-separated value file. So you don't need to list the separator in this case, but if you had something like another character that was separating the columns, you could list that then with something like this sep parameter. So if we had spaces or tabs or some other thing, we could include that. And I think actually in some of the other exercises, we will have a chance to work with data files that have something other than commas separating their values. And then there's a little bit of info here about reading in other data file formats. But let's take a look at what we've read in here by just typing in the name of what we read in data and pressing Shift-Enter. When we do this, you get something that maybe doesn't look super nice. You can see that there's kind of text values in here that start with these pound signs, and then there's a bunch of NaN values and some other text. Essentially, things don't really look quite like maybe what we were expecting here. And well, it turns out there's a good reason for that. We're basically expecting to see 30 rows of data because we have 30 days in June and we have 36 rows of data, which means we've done something wrong. The thing we've done wrong here is that we've failed to take into account that the first 8 lines of this data file are things that aren't actually data, but rather some kind of descriptive text that we should basically ignore when we read in our data file. So we can do that, and it's fairly easy to do. We're going to basically run the same thing we did before, our read CSV, but now we'll add a parameter here called skip rows, and we'll set skip rows equal to 8 so that it doesn't treat the first 8 rows of the file as data, but starts then from line number 9. So I'm going to scroll back up here just for a second to copy what we had before. So let's grab this. when we read in our data file the first time, and let's then scroll back down and paste that into the cell here. So this is the same thing we had done before, data equals pd.readcsv. There's our file name, and the difference now is we're going to add in here skip rows equals 8. And again, what this is going to do is basically not treat the first 8 rows of the file as data, but skip over them and then fill in our data frame starting from row number 9. So press Shift and Enter, and now if I type in data in the cell down here below, things look better now. So you can see, for instance, that now the thing we have at the top of each of the columns is the column heading we were expecting: year, month, and day, temp, max, and min. Okay, those all look good. You can also see here that our first row of values starts on the first day of June. And if we scroll down to the bottom here, you'll see the last row of our data frame is on the 30th day of June. There's 30 days in that month, so that all looks good. And you can see our index now goes up to 29 because it does start at 0. So that does then correspond to 30 rows of data. So that's the way in which we can read in one of the data files. And let's see what we can do with this now that we've read it in. So when you type in the name of the data frame and press Shift Enter, you can see that it prints out the entire data frame to the screen. I think there probably is some limit that if it's more than a certain number of rows, it may not print the whole thing. But typically, especially if you're working with large data files and you just want to quickly look at them, the easiest thing to do is to take the name of the data frame, in this case data, and then .head, which is the function that can be used to display by default the first 5 rows of your data frame. So this is kind of a quick way to check and see, like, okay, I read my data file in, did I get things in the format I was expecting? Like, are all the columns that are supposed to be there, and do the headings for them look correct? So data.head you can do like that. If you wanted to see the first 10 rows, you can just put in a number here when you use data.head. So data.head with 10 in there would give you the first 10 rows of your data file. If all you really want to do is see, like, did I get the sort of columns and data formatted correctly, you can just do data head with 1, and then you can see quickly what the format looks like for your data frame. But that's a nice way to quickly take a look at the top of the values. And if you want to look at the end, you can also type in data.tail. And so when you run data.tail, it does exactly the same operation, but now it shows you the last 5 values or last 5 rows of data in your data frame. So when you first load in a file, I mean, this is a pretty typical thing. You just want to check it out and see did things get read in properly before you start doing any kind of analysis, because if you've read the file in incorrectly, most likely the steps you try to take when you do your data analysis are going to fail because there will be unexpected values in the data that you're working with. So data.tail is the way that we can see the last set of values that are in our data frame. So you can see here that we have these labels for the columns, we have these labels for the rows. So those are ways in which we can reference the data. We can also, for instance, check the data type of our data frame. And we'll use the type function for that like we did earlier in the course. And what you can see is that this is the pandas data frame data type. So again, not really a big surprise, but that's just the way in which you can check to make sure that you have a data frame when you're working with this kind of data in pandas. So your task now is to do what we've done so far. Read in the data file. You have the data file name that we're going to continue to work with into a variable called temp_data. And in this case, your task is to read in only the columns year, moda, and temp. So not the columns max or min. And so as a result, your temp data frame should have 30 rows and only 2 columns. And you can achieve this using the use calls parameter, so use columns. And you can also, if you want to see how to do that, click on the link here to check out the pandas read CSV documentation to see how this use calls parameter is meant to work. So yeah, let's take a minute and read in the data file with only those two columns into a variable called temp_data, and we'll continue after that. But you were asked to basically read in this same data file to a variable called temp_data. So we do this using the pandas read_CSV function. And as before, you're asked to give first the file name, which I'm just going to type KU and hit tab, so it will auto-complete the file name. And then we have to skip our rows like we did before. So we had skip rows equals 8, just like we did before, because we still want to skip the header. But then we have this use calls parameter that we're going to specify. And if you're going to specify more than a single column, you need to put the list of columns that you want out of the file into a Python list by putting it in square brackets. So the columns that we were asked to use in this case should be in quotation marks. And it was year, mo, da, and temp, if I'm not mistaken. So those are our two columns. So we have our data file name, our skip rows parameter, and then our columns name. If we wanted to make this a little bit easier to read, I can also do things like this, which should be fine. It's not a problem to have a line break in between parameters in a function. So file name, skipping the first 8 rows, and then using the columns year, mo, da, and temp. And after we've done that, I'm just going to go ahead and do temp data dot head, not ed, but head, so that we can see what the first 5 rows look like. So read this in. We can see that our temp data frame has only 2 columns as expected, and the first 5 rows look to be correct. So I'm happy enough with that. So that's the way in which we can use this use calls parameter. I think we will use this in this week's exercise. So again, you'll get an opportunity to play with that further. But let's take a look now at some of the other things we can see in our data frame. So there's some familiar functions we can use and some things that are new. If you want to see how many rows you have in your data frame, the easiest way to do that is to go back to our friendly len function that we use when working with lists and put in something like data for the data frame, and the len function will then tell you there are 30 rows in that data frame. Its length is 30 values according to the len function. It turns out, though, there are even easier ways to get access to the same information. For instance, when you create a data frame, we've been using some of these built-in functions. These are like the methods that are, for instance, used here. Like head is a function that's meant to and designed to operate on data frames to give you the first 5 rows of the data frame. There are also things here like that are called attributes. If you remember back from one of our earlier lessons, we talked about methods and attributes. And attributes are values that are stored in memory when the data frame is created. And these include things like .shape. So there's no parentheses after this. It's not a function. It's a kind of basically a variable value for the data frame. And if you check what its shape is, you will be given the number of rows and the number of columns in that data frame. So you can see that our data frame has 30 rows and 4 columns using the shape parameter, which is also quite handy because not only does it tell you the length of the data frame in terms of number of rows, but also the number of columns that are there. And you can see that there are other pandas attributes that might be of interest if you check out the documentation. So we also have ways to take a look at the names of the columns that we have. So we checked out the first 5 rows of our data using data.head. If you just want to see what the names of the columns are, you can just type data.columns. This is also an attribute that's defined when the data frame is created. And what you would see here, for instance, is year, moda, temp, max, and min are the names of the data frame columns. Sometimes, if you don't like all this kind of extra output, you can add dot values to the end of some of these things, and you'll get back a little bit less output. But I think, frankly, that if you're looking for the columns, it's pretty intuitive that the things in here are the names of the columns in the output that you get. So data.columns will tell you the names of the labeled columns you have in your data frame. In addition, we could also check to see what the index values are by typing data.index. And what you see in this case is that it tells us we have a range index. So this is similar to when we use the range function with for loops. The range index here starts at 0 and stops at 30 with a step of 1. If we look at, for instance, I guess it's a little ways back up in the notebook where we had the index values listed, but I'll just add a cell here. And if I do data.tail, it will give me the values at the end of the data frame. And you can see the index goes up to 29. So this is actually the same way that the range function is working, telling you that the starting index value is 0. If we did data.head, for example, we can see that the indexing starts at 0, and data.tail shows us that the last index value is 29. So just like the range function, that stop value you go up to, but do not include that in the labeled or the sort of the range value index that's in this data frame by default. So this is working just like the range function, and the step of 1 obviously is just indicating that the values go up by 1 for each row that we have. Okay, let's maybe take a look at a couple other things, and then you'll get another chance to check in and see how you're processing things. One thing that's a little bit different with a data frame is that you might have different kinds of data in the different columns of your data frame. So if you were to do something like, well, in this case it says pd.dataframe.dtypes. So if we did pd.data.dtypes, I don't think that looks like the right syntax to me. I think this is probably just supposed to be like this. There we go, it's just data.dtypes. That's a little typo in the lesson. What you can see here then is the name of each column and the type of data that's stored as values in that column. So we see the year moda has integer values, whole numbers. If we look back here, that makes sense. The other columns have floating point numbers, which are these float 64s. In both cases, these are represented with 64-bit precision, which is basically just how much memory is used to store the individual numbers in there. And so these are kind of high precision integer and floating point numbers. So we have 2 different data types. If we had character strings in there, we would also see another data type that's listed there. One thing about the columns in the data frame that's maybe a little different than a Python list is it is expected that the data type in a given column is the same for the whole column. So if you try to put a mix of numbers and characters into the same column, you're going to have problems. Pandas, when it reads in a data file, so like let's say you have a data file that has numerical values and text in its format in a given column, Pandas will read things in and try to make a guess for what the data type is that it should use. If it encounters text in the first row, it's going to treat the whole column as text. If it encounters a number, it's going to treat the whole column as a number, and may or may not have problems as a result of that. So that's something just to be aware of. We'll, I think, get into that again with the exercise a little bit. All right, so at this point, why don't we see if you can figure out a way to print out the number of columns in our data frame. And you can type your solution in below, and we'll continue in a moment after that. What you can do with things like figuring out the number of columns is combine the len function, which will tell us the number of rows, for example, if we just apply it to a whole data frame, with something like data.columns. So when we did data.columns before, we saw that there were these 4 different columns. If you do the length or use the len function with the value that is in data.columns, you'll see that there are 4 columns here. So that's the way, if you want to check for the number of columns, that you can do that. To be perfectly honest, I don't think I would do this myself. I would probably just do data.shape and look at the number of rows and columns together at the same time. That's just my approach. So I think instead of doing this, I would probably just do data.shape. And frankly, if you want to get the number of columns from this is a data type we haven't really worked with. It's called a tuple, but it works the same way that a list does, so that you can give index values. If you give the index 0, it would give you the number of rows. If you give the index 1, it will give you the number of columns. So I would probably myself just do data.shape and then put the square brackets 1 to get the number of columns. That's just, I don't know. I find using data.shape is more intuitive to me than len data.columns. But of course, with Python, there's more than one way to solve most problems. Okay, now let's talk a little bit about how to select some of the data out of our data frame. So if we wanted to, for instance, select 2 columns out of our data frame, we can do that by specifying values inside of square brackets. So for example, if we wanted to say selection, we'll make a new data frame here. Selection equals data. And then inside here, we're able to select a certain number of columns. And actually, if you want to select more than one, you're going to put a list inside the square brackets. I'll just add a couple spaces here to make this a little bit easier to read. And inside here, you could give something like year, mode, comma, temp. So inside the square brackets, basically what it expects to receive is a single object, and in this case, it's a Python list with these 2 columns inside there. You don't need the spaces here, of course. I just added them there to make it a little bit easier to read when typing this in. But this would have basically the same effect as reading in our data file and selecting only those 2 columns. So we can run the cell like that, and then we can take a look at our selection by just typing in the variable name selection and running this cell. And when you do that, excuse me, when you do that, what you'll see is we have our year, mode, and temp columns and our 30 rows of data that we had before. So same kind of information that we had previously, but now it is done by selecting values out of a data frame after reading in the whole thing first, rather than selecting only those columns when reading it. What you end up doing in practice may vary a little bit. If you've got a really big data file, it might be more efficient to select only the columns you need at first when you read things in. But here, obviously, the amount of data we're dealing with is not too bad. And if we check the data type of our selection, just run type with the variable selection, you see that this is in fact a data frame as well. So when you take a piece out of a data frame, if you select columns and rows from a data frame, the object you produce is also a pandas data frame. And yeah, because of that, we could do something like if we wanted to selection.shape to see how many rows and columns we have in our new data frame. And if we wanted, we could also select just a single column. And if we were to take, I don't know, a single column like data.temp, or data rather, temp like this, we get a single column that way. And let's assign this maybe as selection 2. And yeah, run that. Our selection 2 is just a single column out of a data frame. And at the beginning of the introduction to pandas, when we were talking about the pandas data frames, we also talked about this data type called a pandas series. And if you take a single column out of a data frame, you get a pandas series. If we check the type of our selection 2, using the type function, what you see here is that our selection 2 variable is a pandas series data type. So it won't have all the same methods and same things that you can do with a pandas data frame, but it operates fairly similarly. So for instance, if we tried to do selection 2.shape, I don't know if this is going to work. I don't think it will. Okay, it does seem to still recognize that there's 30 rows in this in this object. But there may be other methods that don't necessarily work the same between a pandas data frame and a pandas series. Okay, there's also the possibility here to reference values inside your data frame using this data.temp. So if your names of your columns are these kind of like regular character strings, you can basically type data and then the dot and the name of the column in the data frame to access the data. We don't recommend doing this. It's sort of preferable to use this syntax where you have the name of the column you're interested in quotation marks, because this will work for all cases. If you have, for instance, a column name that has a space in it or some other weird character, this won't work. This format just won't be possible to use. So we recommend doing things where you always refer to the column names in quotation marks inside of the square brackets like is shown here. Okay, one other sort of significant thing, and then we'll take a break here. So with our things like our values in our data frame, we can do things like selection. Well, let's do data temp like this. So our single column dot mean. So we can get the average temperature for this column of values by doing the name of the column dot mean. You run that and you can see that it's 59.73 and a bunch of zeros and then a 4. You could also do the same thing for the entire data frame by doing data.mean and then running that. So if you run that, you then get the mean values for each one of the columns. Doesn't really make a lot of sense for the year mode column because you're averaging the dates. But for the others, you get values that maybe make some sense to be able to calculate as mean values. One thing to note here, if you haven't picked up on it already, obviously temperatures of 59 degrees in Kumpula are temperatures in Fahrenheit, not Celsius. I assume that's been quite obvious to you. But I realized, when looking at the mean values, of course, that I didn't actually say anything about that. If you want to get an overview of the values in your data frame quickly, you can do data.describe. And this is a function, so you have to add the parentheses there. And this will give you descriptive statistics about your data frame. So it will tell you the count of the number of values in each one of the columns. And interestingly, you'll see that there are 30 values in the year mode, 30 values in temp, but only 27 in max and 28 in min. So there's some missing data in the file that we read in. It'll also give you the mean value for all the columns, the standard deviation, the minimum value, and then these different quantiles for 25, 50, and 75%, as well as the max value. So this is a handy way to get a quick overview of the data that you're dealing with. I think we'll skip over this example of checking your understanding to print the descriptive statistics for only the columns where it makes sense. You can see how to do this on the course page. But I did want to note here that it is possible to produce very basic plots directly from pandas. So if we take, for instance, you can just run the cells that are here. We've got the temp, max, and min columns out of our data frame, and then we add dot plot. If you run this, what you'll see is you get a plot that looks like this that comes out. Because I'm zoomed in pretty far, it's a little hard to see the entire plot, but there you go. And so you can see then that the temperature values are shown here for the different days in June, as well as the minimum in green and the maximum in orange. And the breaks in the lines here are reflecting those missing data values that were noted already when we looked at the descriptive statistics. There were no missing values for temp, so you get a continuous line for the temperature. And we can start modifying the plots, but we'll get into that stuff in week 7, 2 weeks from now. There's also some stuff here about making pandas data frames out of lists. So you can take a look at that. I'm not going to go through that right now, but there's ways to create data frames from values that are in Python lists, and you can see how to do that on the course page, or if you want to, you can work through the rest of the notebook when you have time. But for now, I think it's about time for us to take a break. Why don't we take 15 minutes so you guys can kind of get refreshed a bit, and we'll continue about 40 after 10. So see you in 15 minutes.